Hello, this is Mr. Eason again with homework help. I might have a lot of new viewers today since it's a new school year. This is lesson 1.1, which covers place value concepts. So we're going to dive right in. Usually the videos work where I explain the concepts on the first slide, and the second slide we go over some of the problems we've done in class. So the first slide is already up here, and all we're going to do is look at this place value chart. And the nice thing is, if you know how to read a 3-digit number, you know how to read a 6 or a 9-digit number. So with a 3-digit number, we've always got 3 place values, and we've always got the ones place, which is here, we've got the tens place, and then we've got the hundreds place. And so if you had a number like this, we just read it 341, because we've got the 3 in the hundreds place, the 4 in the tens, and the 1 in the ones. So all you have to do is apply that to the top portion with 6 or 9 digits, and it's very easy to read because you read 3 numbers at a time, then you apply the bottom label. For example, if I were to put a number in here that says 428, 457. Okay, we focus on this thousands place first, right in here, and we just say 428, then we read thousand, and then it's 457. And if there's a 1, if we're in the ones period, we don't have to say the 1. So we have 428,457. And that's a pretty easy way to say that number. So let's try one more example, and then we're going to move on to the work slide. Okay, so if we have the number such as this, again, we go through and we read the first 3 digits like it's just a 100 number, 328,569. Pretty simple. The other concept that's important here is that we understand what each digit is representing. So if I want to know what this 2 represents, it is in the 20 thousands place, so it represents 20,000. All you do is you take the number that they're asking about, the numbers behind it become zeros, and that's what it represents. So, if we wanted to look at this 8 right here, it's 8, and then we've got 3 numbers behind it, so we put 3 zeros, and it's 8,000. Very simple. And the last one we'll look at is this red 3 right here. It's going to be a 3. And then again, we look at how many digits are behind. We've got 1, 2, 3, 4, 5. So we put 5 zeros behind it. And we got 300,000. Very simple. So now we're going to move on to the next slide. So here is what the sheet looked like that we worked on in class. The first problem is just kind of understanding the groups and what the picture would look like. We don't have a visual for a 10,000, 100,000, or million because it would be just much too large. So we are going to go ahead and we can fill in the shapes. The shapes go in a pattern. We've got a cube, a long, and a flat through here. And then we've got a cube, so the next one would be a long. Then we've got a flat. And the difference is they're just going to be a lot bigger. Now what's more important is this group thing. Okay, we got 1, 1, and then this long here is how many ones, and it's 10 ones. This flat here is how many tens, it's 10 tens. This cube is 10 hundreds, and I hope you can see a pattern here. So this long that represents 10,000 is going to be 10 thousands. So we'd write that in, 10, maybe, 10 thousands. Then over here, this flat for 100,000 would be 10 thousands. And the millions would be 10 hundred thousands. Okay? So So that's pretty simple. Now let's go ahead and look down at the questions that find the value of the underlying digit, which is what we did in the previous slide. We have a 7. So again, we put that 7 out and we count how many digits are behind it. We've got 1, 2, 3, 4, 5. So we put 5 zeros behind it. 1, 2, 3, 4, 5. Put our comma in, and it's representative of 700,000. The next digit we have is a 4. We count how many digits are behind it. It's just 1, so it's a 40. Next digit is an 8. We count the number of digits behind it. We've got 1, 2, 3, 4. So we are at 4 zeros. And the next one is a 5. There are 3 digits behind it, so it's a 5,000. Now, the next ones I want to focus on are a little bit more tricky, but they're very important, so we're going to take a look at them. It says, compare the values of the underlying digits. We've got a 2,000 and a 200. And we want to know, basically, how much bigger is this 2 than this 2. And they kind of set you up with a template here. So the way you fill that in is the value of the 2 in 2,000 is how many times the value in 200? Well, if we looked back at the chart up here, every 1,000 is 10 hundreds. So when you're moving from that hundreds place to the thousands place, it's 10 times as much. So we put a 10 in there. Okay. Next we'll look at the next one, 40 and 400. Now this one's tricky because the 4 in the 40 is not 10 times bigger than the 4 in the 400. So you have to kind of switch it around. The value of the 4 in 400 is how many times the value of the 4 in 40. So the bigger number always goes first in there, and the smaller numbers always go second. And again, how much bigger is the 4 in 400 than the 4 in 40? Basically, they want to know how many 40s are in 400, or how many 10s does it take to make 100, and that's 10. So it's 10 times the value. And that should be all you need to know to get help with the homework for tonight. So good luck, and I will see you in class tomorrow.